Hello everyone, this is Trisha, and now we will be discussing the hypothesis testing z-test 2-sample. A 2-sample z-test is used to test whether two population means are equal. This test assumes that the standard deviation of each population is known. The primary purpose of a 2-sample z-test is to compare means of two independent groups. This would be the formula that we are going to use for 2-sample mean test comparing 2-sample means. So z is equal to mean sub 1 minus mean sub 2 all over the square root of s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2, where the symbol x is the sample mean, s is sample or population standard deviation, n is sample or population size, mean sub 1 is the mean of the first sample, mean sub 2 is the mean of the second sample, n sub 1 is the sample size of the first sample, and n sub 2 is the sample size of the second sample. Let's have the first example. A bank is opening a new branch in one of two neighborhoods. One of the factors considered by the bank was whether the average family income in 1,000 pesos in the two neighborhoods differed. From census records, the bank drew two random samples of 100 families each and obtained the following information. The bank wishes to test the null hypothesis that the two neighborhoods have the same mean income. What should bank conclude? Use alpha is equal to 5%. Let's proceed to step 1. As you can see, our null hypothesis is already says in the given. The bank wishes to test the null hypothesis that the two neighborhoods have the same mean income. Therefore, our alternative hypothesis would be that two neighborhoods have different mean income. In step 2, our given is in the form of z-test 2-sample. Since we compare the means of sample of the independent groups taken from a normal population, our alpha is 0.05 using two-tailed test. Since our alternative hypothesis has the word different, now get our tabular value, which is positive negative 1.96. Let's have first our formula. Z is equal to mean sub 1 minus mean sub 2 all over the square root of s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. Let us first identify the given values. We have sample A and sample B. The mean sub 1 of a sample A is 10,100 and the mean sub 2 of sample B is 10,300. The s sub 1 squared or the standard deviation of a sample A is 300 and the s sub 2 squared of sample B is 400. The n sub 1 or the sample size of sample A is 100 and the n sub 2 of sample B is 100 also. Since we already find the given values, let us substitute each values to our formula. Z is equal to 10,100 minus 10,300 over the square root of 300 squared over 100 plus 400 squared over 100. So our answer would be Z is equal to negative 4. In step 4, the computed z value of 4 is greater than the tabular value of 1.960 using 5% level of significance. And lastly, the step 5, therefore, we reject the null hypothesis. The two neighborhoods have different mean income. For you to understand it, let us have our last example. The average lifetime of 100 brand X alkaline AA batteries and 100 brand Y alkaline AA batteries were given as 4.1 hours respectively. Suppose the population standard deviation of lifetimes are 1.8 hours for brand X and 2.0 hours for brand Y. Test using alpha 0.05 if brand X is better than brand Y. First, we need to analyze the given. We need to test if brand X is better than brand Y. In step 1, our null hypothesis would be the average lifetime of brand X batteries is better than brand Y batteries. Therefore, our alternative hypothesis would be the average lifetime of brand Y batteries is better than brand X batteries. For our step 2, let's put our test, which is the z-test 2 sample. Our level of significance is 0.05 using 1 tilde. Since we use the word better than or greater than and our tabular value is 1.65. Let's proceed to step 3. Our formula, z is equal to min sub 1 minus min sub 2 over the square root of s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. Let us first identify the given values. We have sample A and sample B. The mean sub 1 of sample A is 4.1 and the mean sub 2 of sample B is 4.5. The s sub 1 squared or the standard deviation of sample A is 1.8. The s sub 2 squared of sample B is 2.0. The n sub 1 or the sample size of sample A is 100 and the n sub 2 of sample B is 100 also. Since we already find the given values, let us substitute each values to our formula. Z is equal to 4.1 minus 4.5 over the square root of 1.8 squared over 100 plus 2.0 squared over 100. So our answer would be negative 1.49. In step 4, the computed Z value of negative 1.49 is less than the tabular value of 1.65 using 5% level of significance. And in step 5, therefore, we accept the null hypothesis. The average lifetime of brand X batteries is better than brand Y batteries. For our application, to compare the braking distances for two types of tires, safety engineers conduct 35 braking tests for each type. The results of the tests are shown below. At alpha 0.1, can the engineers support the claim that the mean braking distances are different for the two types of tires? Step 1. Our null hypothesis is there are no difference in the mean braking distances between the types of tires. For our alternative hypothesis, there are difference in the mean braking distances between the two types of tires. In our step 2, since it is z-test 2 sample, we use 2-tailed and our alpha is 0.10 and our tabular value is positive negative 1.65. Let us substitute our given to our formula. Z is equal to min sub 1 minus min sub 2 all over the square root of s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. So Z is equal to 42 minus 45 over the square root of 4.7 squared over 35 plus 4.3 squared over 35. Z is equal to negative 2.79. In step 4, the computed value of 2.79 is greater than the tabular value of 1.65 using 10% level of significance. In step 5, therefore, we reject the null hypothesis. There are no difference in the mean braking distances between the two types of tires. I hope you learned something from this video. Thank you so much.